Wagmare from Kirti M. Dungursi College, Dadar, Mumbai 28. I am teaching chemistry subject in the junior college. And as you know well, yesterday we started with the chapter called Basic Concept of Chemistry. Very first chapter of chemistry. So let us begin with the next part of the same topic.
नाश्ता एकदम कमी आहे बरं म्हणजे
My dear students, in last lecture, we saw some physical properties.
नाही एक प्लेट नको ना माझ्यासाठी एकच आहे कारण की
Okay, so we saw physical property in the last lecture. In that, the first property was mass and weight. Second was volume. Third was temperature. Fourth was density. And when we discussed temperature, that time we discussed three different systems to measure the temperature. Now, very first was we used to measure temperature in degrees Celsius. Even we measure the temperature in terms of Fahrenheit. Then recently we started measuring temperature in terms of Kelvin also. My dear students, in last lecture, if you remember, I have given you formula for conversion of degree Celsius to degree Fahrenheit, and on that basis, today we will discuss few problems based on that formula. Now, if you remember, the formula was degree Fahrenheit is equal to, it is here. Yes, degree Fahrenheit is equal to 9 into temperature in degree Celsius upon 5 plus 32. So this is the formula by which we can convert temperature from degree Celsius to degree Fahrenheit. Now, by using this formula, we will solve some problem, and these problems comes in exam for minimum for 2 marks. Okay, so it is very important formula. Let us begin with. Okay, now, dear students, I have given you 2 examples here. First is 1 degree Celsius and second is 10 degrees Celsius. Suppose I want to convert 1 degree Celsius into degree Fahrenheit. What I should do now? As per the formula, 9 by 5 into 1 that is degree Celsius plus 32, right? If you simplify this, 9 into 1, so that becomes 9 upon 5, right? So 9 upon 5, that comes down 1 point something plus 32, and the final answer is 33.8 degree Fahrenheit. Okay, so very simple it is. 1 degree is a temperature in degree Celsius. So 9 upon 5 into 1 plus 32. When you simplify this, you will get answer 33.8 degree Fahrenheit. Similarly, if you take next problem where I took 10 degrees Celsius temperature, I want to convert to degree Fahrenheit. What I can do? 9 upon 5 into 10. That 10 is a degree Celsius temperature plus 32. Now you know that 9 into 10, that become 90. 90 upon 5, that become 18. 18 plus 32, that comes 50 degree Fahrenheit. Okay, so this is how you can solve the problem, and this kind of problem may come in your examination. That may be your unit test, assignment, terminal exam, annual exam. So you should know this conversion. Similarly, my dear student, you can go other way around also. That you have a degree Fahrenheit temperature and you want to convert it to degree Celsius. So accordingly, you can convert into degree Celsius. It can be both way. Either you can go from centigrade to degree Fahrenheit or Fahrenheit to centigrade. Okay, so this is very, very important. And if you see your regular textbook, in the textbook, these kind of problems are given. You try those problems at home. If you could not get the answer for the problem, right, we will discuss it. Okay, fine. My dear students, today our main lecture begins with this particular part. The name of the topic is laws of chemical combination. The laws of chemical combination. My dear student, you must be knowing that when I told you the definition of chemistry, that time I told you that matter undergoes changes. What kind of changes? Physical change as well as chemical change. I told you the matter doesn't remain as it is. It keep on changing. It keep on changing. So the matter undergo two kind of change. One is physical change, other is chemical change. Now chemical changes, basically they are controlled by some basic laws, and those laws are called as laws of chemical combination. I will relate this thing with our day-to-day life. My dear student, even we being a humans, we live in a civilized society. Our behavior is also controlled by certain rules and regulation. We have been told, don't do this, don't do that. If you do this, you will get this penalty. You will get this kind of fine. And always we take care of those rules and regulation in our real life. Exactly same manner, chemical changes are also controlled by some basic laws. What are the laws? Here are the laws. Number one is law of conservation of mass. Second is law of definite proportion. Third is law of multiple proportion. Fourth is the Gay-Lussac law of gaseous volume. And the fifth one is Avogadro's law. Okay. See, these are the 5 different laws coming under the category laws of chemical combination. But my dear student, you must be knowing today, nowadays, we are facing a pandemic situation of corona, and that's why board has reduced the portion to some extent, and because of that, we are not going to discuss first 3 laws in detail. Okay, I repeat again, the portion is slightly reduced, and because of that, first 3 laws we will not discuss here. If you want, you can go through the law peacefully at home, right? They are very simple to understand. So you can say that is a kind of homework to you. Okay. So basically, in the presently, we are discussing only 2 laws called Gay-Lussac laws of gaseous volume, and the second is Avogadro's law. Okay. Now, please have a look. I'm going back to my previous slide. Substance AB, right? Substance AB react with substance CD. General reaction I wrote. And I get a product called substance AD plus substance BC. You may be knowing that substance AB, substance CD, they are the reactant. Substance AD and substance BC are the product. Okay. So AB is a reactant, CD is a reactant, AD is a product, and BC is also product. Okay. Now, so reactant react and we get a product, and this is the chemical reaction. In fact, the general reaction. I can take many more example of this type. Okay, in a due course of time, we'll take the example. But remember, this chemical reaction, this chemical change is controlled by certain laws. Okay, now let us look at the actual law. Here it comes, Gay-Lussac law of gaseous volume. Now, look at the statement in your examination. Statement may come for minimum 1 mark and maximum for 2 marks. If it comes like state and explain the Gay-Lussac law of gaseous volume, perhaps the weightage may be 2 marks. And if it is only statement, then maybe 1 mark. Okay. Statement I am giving you, statement is as follow. Very simple statement. The law states that when gases combine or are produced in a chemical reaction, they do so in a simple ratio by volume, provided all gases are at same temperature and pressure. So you please prepare this statement thoroughly and write the same statement in examination whenever it is asked. Okay. Now, this is about the statement. Now, look at the example. I will again go back to my previous slide. Okay. Now, look here. Example is very simple. Hydrogen gas, O2 gas. These are the two gaseous reactant. They react together and we get a gaseous product called H2O. H2O gaseous, that means steam. Okay. Now, if you look at the equation, chemical equation, 2H2, 1O2 react together, we get 2H2O. So if someone asks me, sir, what is the volume of hydrogen? So I will say hydrogen volume is 2 times. Okay, hydrogen volume is 2 times. How much is the volume of oxygen? It is 1 time. And how much H2O you are getting at the end of the reaction? 2 times, right? So 2 times H2 react with 1 time O2, we get 2 times H2O. And if you ask me the ratio of the gaseous reactant and gaseous product is the 2:1, 2:1:2. Okay, that is what the ratio is. Look at the previous statement. What they said, when gases combine or are produced in a chemical reaction, they do so in simple ratio, right? Now in this example, the ratio is 2:1:2, right? The same thing, it is pictorially represented. I took 2 molecules of hydrogen. In box, you can see those 2 molecules of H2, 1 molecule of O2 in a box. After combining, we are getting 2 molecules of H2O, right? So 2 time volume of hydrogen combined with 1 time volume of oxygen, and that gives me 2 volumes of water. Okay, so this is what the reaction. So the ratio is going to be 2:1:2. Okay, right. So remember, this is the one example which is cited in our textbook. But remember, likewise, many more examples can be given in examination. Teacher will give you different reaction, but the basic pattern remains same. Now look at my next example. Now, you can see here 1 volume of H2, react with 1 volume of chlorine. We get 2 volumes of HCl. If I ask you what is the ratio here, the ratio is 1:1:2, right? Similarly, in the previous example, 2 volumes of hydrogen, 1 volume of oxygen, combined together, we get 2 volumes of water vapor, right? So the ratio is 2:1, right? Similarly, look at this example also. Here, the example is 1 volume of H2 react with 1 volume of chlorine, gives me 2 volumes of HCl. This is again very famous equation. If you ask me the ratio is 1:1:2. Likewise, there are many more examples you can practice, by using various study materials, and you practice them. Now look here, another example. Nitrogen gas allowed to react with hydrogen gas gives me ammonia gas. So nitrogen in coefficient, what is the coefficient for nitrogen? 1. What is the coefficient for hydrogen? 3. What is the coefficient of ammonia? Appears in the equation 2. So the 1 volume of nitrogen combined with 3 volume of H2 gives me 2 volumes of ammonia. Suppose if I ask you, in the present example, what is the ratio? What is the simple ratio? The ratio is so simple. The ratio is 1:3:2. 1:3:2, right? So simple it is, right? Okay, so that is about the one more example, right? You can see pictorial, it is represented 1 molecule of N2 react with 3 molecules of H2. Combined together, we get 2 molecules of ammonia. Now, for a better understanding, even the pictorial representation is shown here. The student who are not able to understand, by looking at the chemical equation, for those students, the same thing is represented pictorially. Okay, so that is about the Gay-Lussac law of gaseous volume. In today's lecture, we will also see some problem based on Gay-Lussac law of gaseous volume. The problem comes for 2 marks. Okay. Now, look at the next law, what we are going to discuss. The law is called as Avogadro's law. Avogadro's law. Now, look at the statement. Look at the statement. Go through the statement peacefully. Having any problem, you are welcome to us. You're welcome to us. Now, statement goes something like this. Look here. The law states that equal volume of all gases at the same temperature and pressure contain equal number of molecules. Okay, this is what the statement. Very simple statement. You by heart the statement and try to write the same statement in examination if it is asked. Statement may give you minimum 1 mark and maximum 2 marks. Okay, so that is what the statement of Avogadro's law. For your understanding, for your information, let me tell you this Avogadro's law, it was given in the year 1811, 1811. That was the year in which the law was given, okay, by the Italian scientist called Avogadro. Now, look at the beauty of the law. Look at the beauty of the law. Now, example is, same example I am giving you here. 2H2 gas react with O2 gas, give me 2H2O gas, right? So as we discussed 2 few minutes back, volume of hydrogen 2, oxygen volume 1, water form, that is 2 volume. Okay, now look here, this is as per the Gay-Lussac law. This is as per the Gay-Lussac law. And if you look, let us apply the Avogadro's law. Okay, now as I said, Avogadro's law was given in the year 1811 and the Gay-Lussac law was given in the year 1809. Right. Only the Gay-Lussac law comes into use after Avogadro's law only, because Avogadro's law help us to understand the Gay-Lussac law. Okay. Now, in this present example, we are taking support of both the law, that is Gay-Lussac law as well as Avogadro's law. Now, here we say 2N molecule, right? Because hydrogen present 2 times, O2 present 1 time. So, obviously, when hydrogen is 2 times, number of molecule is 2N. And oxygen is 1 time, the number of molecule is N. That means 2 times of N, 2 times of N, that is 2N. Okay, 2N molecule of H2 and N molecule of O2. And how many molecules of H2 we are getting here? We are getting 2 molecules of H2, right? So that is what. Acha. Now I will tell you one thing here. Look here. So if I substitute N ka value 2, N ka value 1, so 2 into 1, that become 2, that become 2. Can you see here? 2N. So I wrote N ka value 1, so 2 into 1, that become 2. N ka value 1, that is here 1. And here again 2 into N, that is N ka value 1. Again answer coming down equal to 2. Okay. So this is as per the Avogadro's law. Okay, now let me go back to, if in your board exam, if in your college exam or maybe board exam, suppose the problems comes on this particular law. then you should solve the problem in this manner. Okay, in this manner. My dear students, I want to tell you when it comes in exam to write, state and explain Avogadro's law, then you can write what you see in the slide as it is. Okay. But suppose I want to explain same thing in a still simpler manner, then I can say in this way. Please have a look here. See the what I say here. Equal volume of all gases, right? Suppose, for example, I am taking hydrogen gas. How much? 1 liter hydrogen gas. And that 1 liter hydrogen gas contain, say, for example, 1 lakh molecule, 1 lakh, right? So if you take same amount of chlorine gas, then that gas also will have a same number of molecule. Are you getting me what I'm saying? I say if I take 1 liter hydrogen and 1 liter chlorine, so then both the gases will contain equal number of molecule as long as temperature and pressure is same. Right? I can give us one example. Suppose you purchase a seal packet of pen. Okay. In one packet, there are 10 pens are there, 10 pens. And if you purchase another packet of same type, okay, so in that packet also will have the same number of pen, right? It doesn't happen to one packet 10 pen, second packet only 5 pen, 7 pen, 9 pen. No, as long as both the packets are sealed, both the packets are of same company, then the number of item remains same. Exactly same thing in equal volume of all gases contain equal number of molecule as long as temperature and pressure remains same. Okay, so take 2 minutes to go through all these two laws, right? And I hope you will understand this very nicely. It is given in the book. All examples are given from your textbook only. Okay. So when it comes to write, state and explain Avogadro's law, write what you see in this slide. Okay. So that is about the Avogadro's law. Okay. I hope you must understand. Let us go next slide. Now, students, for your better understanding, what I'm going to know now, please have a look here. I have to tell you, yes. Now, my dear students, in this chapter, I want to introduce a concept called mole. My dear student, suppose if I ask you, what is the normal units used for measuring the object in real life? Suppose if I go to the shop and I say, give me 1 dozen banana. So how many 1 dozen contain? How many items contain in 1 dozen? So you will say, sir, it was so simple. In 1 dozen, there are 12 items. That item can be pen, pencil, rubber, banana, guava, mangoes, whatever. So 1 dozen is always equal to 12 items. Then we use higher unit, 100. And 100 is again we use 1000 for counting. But my dear student, when it is time come to count microscopic particle, that is can be atom, ion, electron. So we cannot use this regular unit for counting. You cannot count number of atom in terms of dozen. You cannot count number of ion in terms of dozen, in terms of 100, because they are innumerable. You cannot count the number of stars present in the sky because the number is so huge. And to count such a large number of tiny particles, these regular units, they are of no use. And that's why chemists. Now, let me clear one misconception about chemists. Normally, in our India, the person who sells the medicine, we call them as a chemist. No, it is wrong. The one who sells medicine is called as pharmacist. And one who is working in the field of chemistry, one who is a very knowledgeable person in the field of chemistry is called as chemist. The chemist can be, any scientist. You can have an example of Einstein, right? Then you can say the Gay-Lussac, Avogadro, they are called as a chemist. So people like this, they sit together, they discuss what can be done, what term can be used for counting such a large number of tiny particles. And they decided we will use a mole. Now, look at the mole, definition of mole. Meaning is given, 1 mole is the amount of substance that contain as many entities. In simple word, entities का मतलब particle. The particle can be either atom, it can be ions, it can be electron, it can be molecule, as they are atoms in exactly 12 grams of the carbon 12 isotope, right? So this is what the meaning is. In fact, I will tell you after 2 minutes, okay, how many number is that? 1 mole equal to how much? I will tell you after 2 minutes, right? So this is the textual definition of mole. You should remember it, you should by heart it, and you should try to write same in examination, right? So you will get 1 mark for the same. Okay, very simple. Amount of substance that contain as many particles as there are atom in exactly 12 grams of the carbon 12 isotope. Now, my dear student, I will explain you this definition. Suppose I am taking 12 gram carbon sample, 12 gram carbon sample, okay? And if I analyze that carbon sample 1 by 1, and if I count the number of particles present in that 12 gram carbon sample, whatever the entities I will come across, that entity is called as mole. That entity is called as mole. Now you will say, sir, why only carbon 12 isotope? Why not anything else? My dear student, you must be knowing previously we used to compare it, we used to compare with hydrogen. In my last lecture, I told you the meaning of units. Unit, we always have some standard with us, and with that standard we compare. So for comparison, in olden days, we used to take hydrogen. But moment isotopes of hydrogen were discovered, then the problem was started. Because you know that there are 3 isotopes of hydrogen, 1H1, 1H2, 1H3. Right? So moment these 3 isotopes of hydrogen were discovered, then the problem was started. Then scientists said that, okay, let us ignore hydrogen and take carbon 12 into consideration. And that's why in the definition, carbon 12 isotope is come. By the time, I want to tell you how to calculate number of atoms in 12 gram of C12 isotopes. Okay. My dear student, before I proceed further, I must tell you the meaning of isotopes. Okay. Maybe some of the students may not be knowing the meaning of isotopes. So it is my, duty that I must tell you the meaning of isotopes. Just now I quote one example, 1H1, 1H2, 1H3. So in all the 3 cases, hydrogen का atomic number is 1, but mass number keep on changing. एक जगह 1, second is 2, and the third is 3. 1, 2, 3. So isotope I can say like this: isotopes are the different atoms of the same element. Isotopes are the different atoms of same element having same atomic number but different mass number, right? So that definition you will again learn in the in this academic year. Okay, what are the isotopes? Okay, so now look at the how to calculate number of atoms. Now mass of one carbon 12 atom is 1.992648 into 10 raised to minus 10 raised to minus 23 kilogram. Okay, now this is all statistical data. Mass of 1 mole of carbon atom is 12 gram. Okay. Now, number of atom in 12 gram of carbon, C12 is, can be calculated. Weight of a substance, how much it is? 12 gram mole inverse. Now, this is the atomic mass of carbon upon 1.992468 into 10 raised to minus 23 gram atom, 10 raised to minus 23 gram atom raised to minus 1. And if you simplify this, the answer is coming down to 6.0221367 into 10 raised to 23 atom mole inverse. Now, go through the calculation properly. That is how we can get the number of atom in any sample. Presently, we bother carbon 12 isotope. We took 12 gram sample and we got this many number of atoms in that sample. Okay. Now, my dear student, let me tell you one thing here. Avogadro, the scientist who introduced the concept of mole, he said that 1 mole is equal to this many particles. 1 mole is equal to this many particles. Look at the figure. Now remember this figure. By heart the figure. If someone asks you in the sleep also, no, you should be able to tell this figure. 1 mole is equal to this many particle. The particle can be atom, particle can be molecule, particle can be ions. Now we are talking about the element. Carbon is element. So we talk about atom. Suppose I'm talking about compound, then I will be having molecule, right? Molecule, right? So that is about the number of atom present in 12 gram of carbon 12 isotope. Now, so this is very important statement here. Very important statement here. Thus, 1 mole is the amount of substance that contains 6.0221367 into 10 raised to 23 particles. Okay. My dear student, if you want to quote the figure, now you can write only up to 3 digits. Will do. That is 6.022. Aage ka fraction, you leave that fraction. Don't bother that. 1367, no need. Only write 6.022 into 10 raised to 23 particle. Okay. So that is about the number of particle present. Okay. Now, my dear students, look here. Mass, 1 minute, 2 minutes back, I discussed atomic mass. Now let us talk about molar mass. Mass of 1 mole of a substance, that substance can be element or can be compound, in gram is called as molar mass. Go through the definition, go through the meaning. Molar mass of any element you can express in terms of gram and is numerically equal to atomic mass of that element. My dear student, earlier we used to express atomic mass in terms of atomic mass unit. Now that term atomic mass unit is replaced nowadays by the term called unified mass. Now here you can look here, this symbol, see this is symbol, U for unified mass. Earlier it was atomic mass unit, AMU. Now that AMU is replaced by unified mass. And for that unified mass, symbol is small u. There's another symbol, DA for Dalton. You must be knowing Dalton atomic theory. For your knowledge, some elements and their atomic masses are quoted here. Hydrogen ka atomic mass 1 unified mass, carbon ka atomic mass 12 unified mass. Oxygen ka atomic mass 16 unified mass. If you talk about molar mass, then the figure remains same. Only you say that per mole. है ना, मतलब हाइड्रोजन का मोलर मास 1 ग्राम मोल इनवर्स, कार्बन का मोलर मास 12 ग्राम मोल इनवर्स, ऑक्सीजन का मोलर मास 16 ग्राम मोल इनवर्स. Okay, so that is what about atomic mass and molar mass. Go through the slide properly. Okay, okay, so that is about the molar mass. Now similarly, molar mass of any substance existing as a polyatomic molecule, and even that can be expressed in terms of grams, and is numerically equal to its molecular mass of formula. Molecular mass or formula mass, and that can be expressed in terms of unified mass. Now, for example, my dear student, polyatomic substance. I am taking O2 molecule. When I say poly, poly means many, more than two. है ना? O2 contain 2 oxygen atom, H2O contain 3 atom, NaCl contain 2 atoms. So O2 का mass 32 unified mass, H2O का mass 18 unified mass, NaCl का molar mass 58.5 unified mass. Molar mass, when you export same figure, you can put unit called gram mole inverse. Figure remains same. Figure remains same. Figure remains same. Now here, here, look here. This is 32 unified mass, and this is 32.0 gram mole inverse. Here 18 unified mass. Here 18 gram mole inverse. Okay, so that is what the difference is. Okay, now here, now look here, number of moles of gases can be found more conveniently by measuring volume rather than mass of the gas. Rather than mass of the gas. What does it mean? It means that suppose I want to calculate number of moles, better is you should consider volume rather than considering the mass. Rather than consider the mass. Okay. So whenever, in fact, when we will solve the problem based upon Avogadro's law, based upon Gay-Lussac law, we will always take into account volume, not mass. Mind well. Okay, so that is about the number of moles. How to calculate? According to Avogadro's law, 1 mole of any gas occupies a volume equal to how much? 22.4 decimeter cube at STP. Even this figure you can remember. 1 mole. You take 1 mole of any gas. Gas can be hydrogen, chlorine, ammonia, right? They all will have a same volume, that is 22.4 decimeter cube at STP. STP का मतलब क्या होता है? Standard conditions of temperature and pressure. Okay, this figure you remember. Then the volume of 22.4 decimeter cube of STP is known as molar volume of gas. You will say, sir, 1 mole of any gas, you say it is equal to 22.4 decim cube at STP. And that 22.4 decimeter cube volume is also called as molar volume of gas. Okay, so that is about the molar gas volume. Okay, next. Okay, number of moles of a gas. How to calculate? For that, we have a formula here. Volume of a gas at STP upon molar volume of a gas. My dear student, remember this formula. This formula will help you out to solve the problem. This is the formula which can be used to solve the problem. Okay, fine. Next, number of moles of gas. All right. Molar volume is, you know, it is 22.4 decimeter cube. I substitute the value here, 22.4 decimeter cube. So this is what I get. Now my next step is what? Number of molecules. Number of molecule equal to, once you get the number of moles, no, you can calculate number of molecules. How to calculate number of molecules? Number of molecules can be calculated by this formula. Number of molecules equal to number of moles into 6.022 into 10 to 23 molecules. Okay. So this is again second formula, which is very useful to solve the problem. Okay, you remember this formula for solving problem. Hopefully, in my next lecture, we are going to solve problem based on these two equations. Okay, now, so remember this formula. My dear student, I want to tell you one astonishing fact for the work of scientist Avogadro. He was awarded a Nobel Prize. You will shocked to know कि sir, how it is possible, because when suppose someone tell you कि sir, this is what 5 decimeter cube of gas given to you, 5 dm cube gas is given to you, tell me tell me the number of molecule present in that sample. You will say no, this is not possible. When we cannot see the gas, how we will count the particle? When we cannot see the gas, we cannot count the particle. Solid particle can be counted, agree. But gaseous molecule, liquid molecule cannot be counted. But those counting was become possible only because of work done by scientists called Avogadro, right? And that's why the gentleman was awarded with a Nobel Prize. So in my next lecture, we will solve the problem based on these two formulas. This is one formula, number of moles, ये one formula है, and this is number of second formula, number of molecule equal to number of moles into 6.022 into 10 raised to 23 molecule. On these two formulae, we will solve the problem in our next lecture. I express my thank you to each and every one. Thank you very much. Thank you.